Let us continue. Alcohols, phenols, ethers, subjective questions. Now we will take a C10H12O. C10H12O we will take. This C10H12O is isomers of A and B. It forms isomers A and B. It is insoluble in aqueous sodium hydroxide. It is insoluble in aqueous sodium hydroxide. Okay. The C10H12O is insoluble in aqueous sodium hydroxide, we can say. This decolorize bromine in CCl4. This decolorize bromine in CCl4. Decolorize bromine in CCl4. This decolorize K-monO4. This decolorize potassium permanganate. This decolorize potassium permanganate. Then A undergoes vigorous oxidation. A undergoes vigorous oxidation. A formula is what? C10H12O. Vigorous oxidation to give to give what in the sense para anisolic acid. Para anisolic acid. B undergoes vigorous oxidation to give carboxylic acid. A on ozonolysis gives compound. B also on ozonolysis gives same compound, same products. Both are giving same products. So this then for this C10H12O, third isomer is possible. That is C. That on oxidation gives what in the sense para-anisic acid. Para-anisic acid. This isomer A, isomer B and isomer C, all on hydrogenation give same product they will give. This A, B, C, all on hydrogenation give same product. This A, B, C, all on hydrogenation gives same product, we can say. Now what are A, B, C? We have to find. Sir. Now here one oxygen is there. This oxygen is there means for this one possibility alcohol in the sense phenolic possible, phenolic OH group possible, alcoholic OH group possible. OH group is there in the sense with sodium hydroxide. Some alcohols do not dissolve in sodium hydroxide, but some of the alcohols dissolve in sodium hydroxide. Phenols dissolve in sodium hydroxide. Some alcohols do not dissolve in sodium hydroxide. Some alcohols dissolve in sodium hydroxide. Because acid-base reaction. Alcohol acts as acid, sodium hydroxide acts as base, gives salt and water. Okay. So alcohol behaving like this. Then here C10 is there. C10 is there in the sense if the number of carbon atoms more than 6, then in both side think it aliphatic side and another thing is a phenyl side, phenyl, benzene, that side also we have to think. For that we have to see hydrogens, for which whether it is having benzene ring or not, how to check in the sense take formula CnH2n plus 1, n is equal to substitute 10, H is coming how much? H is 21 is coming. Okay, H is 21 is coming, but how much H is there? 12, much less. If number of hydrogens much less when compared to this formula, then what possibility is there means phenyl ring is possibility is there. Sir, phenyl ring possibility is there. For that, what is the evidence? Phenyl ring possibility is there. For that, what is the evidence means they said para-anisic acid. Para-anisic acid, what is the formula? First we will take anisole. Anisole is OCH3. Para-anisic acid, acid in the sense carboxylic acid. So para-anisic acid is acid. Para-anisic acid means like this. Anisole formula, benzene with OCH3, anisole formula. Para-anisic acid means at para position carboxylic acid is there, that is the meaning. So this indicates that, okay, this indicates that here this para-anisic acid that is there, that meaning that says that here benzene ring is present. The C10H12O is having benzene ring. Sorry, okay. So C10H12O is having benzene ring. Okay. It is having one oxygen. This oxygen is not alcohol. That is most probably confirmed. Okay. But it may be also alcohol because some of the alcohols are insoluble in water, insoluble in aqueous sodium hydroxide. Okay. Some of the alcohols soluble in aqueous sodium hydroxide. Phenols, no doubt soluble in aqueous sodium hydroxide. Therefore, this O is not a phenol. Phenol in the sense OH group directly attached to benzene ring. If OH group is directly attached to benzene ring, then that is phenol. Certainly, it is not phenol because phenols are soluble in sodium hydroxide solution. Therefore, it is not phenols because they said insoluble in sodium hydroxide. No? Therefore, it is not phenols. Okay. Next, this isomer decolorizes bromine in CCl4. Decolorizes bromine in CCl4. Okay. Decolorizing bromine in CCl4 in the sense certainly C double bond C is there, otherwise C triple bond C is there. Either C double bond C or C triple bond C, that must be localized. Benzene also containing pi bonds, but benzene containing pi bonds are delocalized. This delocalized benzene pi bonds do not decolorize bromine in CCl4. This delocalized pi bonds do not go for addition reaction normally. Under drastic condition only addition reaction possible. Therefore, this benzene containing pi bond, that pi bonds do not decolorize bromine in CCl4. Okay. Therefore, this isomer is having double bond is there conformly. CC double bond is present. Sir, okay. This is containing CC double bond. Sir, okay. That is confirmed. CC double bond is present. How it is present, we have to see. CC double bond is present. Otherwise, a triple bond also, because decolorizing bromine in CCl4 in the sense a double bond as well as triple bond. Okay. So this says that CC double bond, otherwise CC triple bond present in this isomer. In this C10H12O, this is there. Okay. Then decolorizes K-monophore. Decolorizes K-monophore means what? That we'll see. For that, we will take an example. What is the example we are taking in the sense ethylene we will take. Then we will add what in the sense aqueous solution. Aqueous solution means this. Alkaline K-monophore. Alkaline K-monophore. This K-monophore acts as oxidizing agent. Therefore, it gives nascent oxygen. And cold condition is provided. What happens means hydroxylation is possible. Hydroxylation means CC double bond is converting into single bond, and here one OH group is added, here one OH group is added. Okay. At this carbon, one OH group is added. At this carbon, one OH group is added. Therefore, this process we can say hydroxylation. Okay. This process is called Bayer's reagent. It is called Bayer's test. This ethylene is colorless. Water is colorless. K-monophore is violet. This glycol is colorless. Therefore, in this reaction, K-monophore color disappears, we can say. Therefore, this C10H12O decolorizing K-monophore in the sense Bayer's reaction takes place. It is Bayer's reagent. That means here localized CC double bond is present. Okay. So, this decolorizes K-monophore and decolorizes this one bromine in CCl4 confirms that in this isomer localized double bond is present, otherwise localized triple bond is present. Sir, okay. Next we will see this isomer A on vigorous oxidation. gives para-anisic acid. Anisic in the sense anisole. Okay, that means this A, we will take A. A is giving what in the sense para-anisic acid. Para-anisic acid. Anisic acid is this. That means here side chain. This side chain can be anything. Side chain can be anything that will convert into carboxylic acid on vigorous oxidation. That means this ether is not undergoing, is not come from oxidation. Ether do not go for oxidation. Therefore, ether do not go for oxidation in the sense at para position ether should be there. At para position ether should be there, that do not go for oxidation. Here at para position ether is there, means at para position ether should be there, this do not go for oxidation. So side chain can undergo oxidation. Okay, now how when the side chain will undergo oxidation? Side chain carbon, that means the carbon attached to phenyl ring must have hydrogen, then the side chain will convert into carboxylic acid. Side chain can be methyl group, ethyl group, n-propyl group, butyl group, isobutyl group, whatever the thing. The carbon which is directly attached to phenyl ring must have hydrogen, then that will undergo oxidation to give carboxylic acid. Okay, sir. So side chain can be what, that we'll see. Now we got some idea. This oxygen may be ether. This oxygen is ether, we got an idea. Alcohol is not. Okay, phenol also not. C10, in that C10, in this benzene is having 6 carbons. This ether, this side chain, this ether group is having 1 carbon, 7 carbons is over, remaining 10 carbons are there. 2 carbons we have written, third carbon also we have written. So one possibility is like this. What is another possibility in the sense? Another possibility like this also we can say. Another possibility like this we can say, that 3 carbons we have written, and double bond we have written. Okay, double bond we have written now. So double bond position we have changed. So here 1 nitrogen possible, here 1 nitrogen, here 3 hydrogens possible. This one on vigorous oxidation, this side chain will convert into carboxylic acid. Here we will see it is CH2, this is CH, it is CH2. On vigorous oxidation, this side chain is converting into what in the sense? Carboxylic acid we can say. Sir, so we got carboxylic acid, we got, sir. Okay, so this is on site, this on vigorous oxidation converting into carboxylic acid, this also on vigorous oxidation converting into carboxylic acid. Now A on vigorous oxidation gives para-anisic acid, B on vigorous oxidation gives para-anisic acid, third isomer C on vigorous oxidation gives para-anisic acid. So also is formed. Now this A, B, C on hydrogenation gives same product. Okay, this we will take for hydrogenation. Hydrogenation means a double bond is converting into single bond. Here 1 hydrogen is added, here 1 hydrogen is added, that we can see. So CH2, CH2, CH3. We are having this phenyl ring and this OCH3. Okay, this also on hydrogenation gives this product. Okay, so we can say what in the sense this is one isomer, this is another isomer of C10H12O we can say. Sir, now see, A on ozonolysis gives what product? Same product is given by B on ozonolysis. Suppose it is A. This on ozonolysis gives what product? We will see. This on ozonolysis, we have what we have to do? Break the double bond. CC double bond, you break it. We have to break CC double bond. Okay, CC double bond we have broken. Okay, we have broken CC double bond. On either side of CC double bond give oxygen. Okay, therefore this is one product, it is another product. Okay, this is A. If you take this is as a B, This on ozonolysis gives what product we will see. This on ozonolysis break CC double bond. Okay, we have broken CC double bond. So we have broken CC double bond and we have got like this side one oxygen, this side one oxygen, add it. Now you see here products, A is giving like this products, B is giving like this products on ozonolysis. They are not same. Therefore, this is not B. Okay, this is not B. This is not B. Therefore, we will say suppose C. C we will say because three isomers, no, A, B, C, three isomers. Then what is B? Why we said this is not B? Because A and B both on ozonolysis give same product. So it is A means what is B? It is not B. Therefore you keep this is as C. What is B? What is B means you see this one. Here this double bond carbon contains hydrogen. This double bond carbon contains hydrogen. Both hydrogens are on same side. Therefore it is cis. So A is cis means what is B? No doubt it is trans. That's all. Correct? A and B are isomers, they said. A and B are isomers. Now see, isomers of A and B. A and B are what isomers? Geometrical isomers. A is cis, B is trans. Geometrical isomers. A and B are isomer of C. How it is isomer of C? In this isomer double bond position you see. In this C isomer double bond position you see different. Position of double bond is different. Sorry. Here we said CC double bond is present, we said, and also we said another point, CC triple bond also possible, we said no. But we did not consider CC triple bond, we have considered CC double bond and proceeded and we said ABC, whether it is correct or wrong. Whether here double bond will be there or triple bond will be there, how to confirm it? Count the hydrogens and you see, here hydrogens are 12. Here hydrogens how many will see? Here 3. Here 3, 6. Here 2, 8. Phenyl ring contains what? Here 1, 2, 3, 4. So 8 plus 4, 12. So if we give double bond, 12 hydrogens coming. If we give triple bond, 10 hydrogens only will come. Therefore, here hydrogens 12 means 12 hydrogens will come if we give CC double bond. Therefore, a double bond, localized double bond possible, but not localized triple bond. That's what we can say. Sir. Next, we will go for another subjective question. Now, C11, H13, C11, H13, OCl, C11, H13, OCl has two isomers. It has two isomers. What are the two isomers means A and B. This on catalytic hydrogenation. It is going for catalytic hydrogenation. It is going for catalytic hydrogenation to give some compound C. Some compound C. This on vigorous oxidation. This on vigorous oxidation gives a compound carboxylic acid is directly attached to phenyl ring. Here ether is there. Here ether group is present. Here Cl is present. Okay. Now A as geometrical isomers. A as a geometrical isomerism. A can show geometrical isomerism. B is not showing geometrical isomerism. B is not showing geometrical isomerism. Okay. A is showing geometrical isomerism. B is not showing geometrical isomerism. Okay. What is ABC? We have to say. Okay. What is ABC? Okay. First check here it is here. And no doubt they said this on vigorous oxidation gives like this phenyl ring in the sense. No doubt here phenyl ring is present. Okay. That C11 contains phenyl ring. Okay. Then in this phenyl ring, ether is there. Ether will not be obtained by vigorous oxidation. Ether will not go for vigorous oxidation. So this ether you take as it is. chlorine also will not be affected by vigorous oxidation. Therefore this chlorine also you write it. Okay, now at this place carboxylic acid is there. Now 11 carbons are there totally. This phenyl ring contains 6 carbons, ethyl group contains 2 carbons, totally 8, remaining how much? Benzene ring contains 6, ethyl group contains 2, totally 8, remaining is how much? 3. That 3 carbons should be at where? Correctly at this place as a side chain. That 3 carbons must be as a side chain. This side chain must undergo oxidation and gives carboxylic acid. Therefore, this C3 can be what? That we'll see. This C3 contains 3 carbon atoms. That 3 carbon atoms we have written like this. Okay, this here OET, here Cl. Now, A is undergoing geometrical isomerism, which will show geometrical isomerism. CC double bond will show geometrical isomerism. Therefore, one possibility double bond here will give, another possibility double bond will give here. Okay. So now we have written like this. Here OET, here Cl. Okay. Double bond here means we will give hydrogens. We will give hydrogens like this. This will not show geometrical isomerism. So now geometrical isomerism for this. B will not show geometrical isomerism. Therefore, this is B. Here we will give hydrogen. Here we will give hydrogen. It can show geometrical isomerism. It is showing geometrical isomerism. Therefore, it is A. Okay. Now this on this A and B on hydrogenation. Hydrogenation means a double bond is converting into single bond. Then we are getting so and so compound. Both are giving same compound, that is C. Both are giving both A on catalytic hydrogenation gives C. B also on catalytic hydrogenation gives same compound C. Therefore, what is A means this compound, what is B means this compound. That's what we can say. Okay, so A and B we said. A is showing geometrical isomerism means that is cis and trans we can say. Cis isomer and trans isomer we can say. Okay, sorry. Next subject question we will take. We are taking acetylene. We are taking acetylene. This acetylene is treated with 2 times sodium and 2 times carbon dioxide. Then taken for hydrolysis, we are getting A. This A is treated with what in the sense? Sodium in liquor ammonia and in ethanol solvent. What we are getting means B. This A with palladium catalyst and hydrogen and calcium carbonate. Calcium carbonate in the sense it is catalytic poison for palladium. Gives C. Now, what is ABC? What is ABC? They are asking. Okay. First, we will see acetylene. We will take. Acetylene will react with sodium. Acetylene will react with the sodium. We will take. Acetylene is reacting with the sodium to give what we will see. Sodium is giving electron and sodium becomes Na plus. Sodium loses one electron and becomes Na plus. This electron is taken by hydrogen. This bond is shifting here. Okay. Then another sodium is giving electron. That electron is taken by this hydrogen. This bond is shifting here. Then sodium is becoming Na plus. Okay. So this C is taking this bond and becomes C minus. This triple bond. The triple bond will take this C also taking this bond. Therefore, that becomes C minus. This Na plus goes near the C minus. This Na plus goes near the C minus. Then this H and this H becomes hydrogen gas. Hydrogen gas is liberating. It is called sodium acetylide. It is called what means sodium acetylide. So we got sodium acetylide, we got. Therefore, now what we got in the sense acetylene on reaction with sodium we got. Acetylene on reaction with the sodium we got. Then reaction with the carbon dioxide. Then reaction with the carbon dioxide. First reaction with the sodium, then reaction with the carbon dioxide, then reaction with the hydrolysis, water in the presence of acid. Now carbon dioxide we will take. Okay, we have taken carbon dioxide. What happens means the C minus is having lone pair. That lone pair is attacking this carbon. This bond is shifting. Then another carbon dioxide, we will take another carbon dioxide. This C minus is having lone pair. That lone pair is attacking this carbon. This pi bond is shifting. Therefore, what we will get, that we will see now here. This carbon is making bond with this carbon. Okay, carbon carbon bond. This carbon is having double bond O, and this carbon is having single bond O minus. Okay, then this triple bond we will take. Okay, triple bond. This carbon we will write. This carbon is making bond with this carbon. That carbon is having double bond O. This carbon is having single bond O minus. Okay, single bond O minus we have written. Then this is treated with H plus in the presence of water. Water in the presence of acid. Okay, H plus. This O minus taking H plus. This O minus also taking H plus. Therefore, it becomes carboxylic acid. Okay. So we are getting a so triple bond C, COH, double bond O. We got carboxylic acid. This is what in the sense A. So we got A. This A with palladium, hydrogen and calcium carbonate. Palladium, hydrogen and calcium carbonate. Palladium hydrogen means catalytic hydrogenation. That means CC triple bond is going for catalytic hydrogenation. Calcium carbonate is there means this is poisoning the palladium. Catalytic poison is there. Due to catalytic poison, this triple bond is converting into CC double bond. Triple bond is undergoing hydrogenation with hydrogen. Catalyst palladium is there. This palladium catalyst can convert CC triple bond into CC single bond. But due to catalytic poison, calcium carbonate, triple bond is converting into double bond, CC double bond. This catalyst is called what in the sense Lindlar's catalyst. Lindlar's catalyst converting CC triple bond into CC double bond and also gives cis isomer. So CC triple bond is converting into CC double bond. What compound is obtained means cis isomer is obtained. This side 1H, this side 1H. Cis isomer. Therefore, here one carboxylic acid, here one carboxylic acid. It is called Lindlar's catalyst. Lindlar's catalyst will convert CC triple bond into CC double bond and give cis isomer. It will give. Therefore, this compound C is this one. Okay. Next, compound B we will see. Compound B we will see. Okay. This with what in the sense sodium ammonia, sodium in liquor ammonia in the presence of ethanol is a solvent. Sodium in liquor ammonia in the presence of ethanol is a solvent. What is obtained, that we will see. Oh, now ethanol. Ethanol is reacting with the sodium in what way? Sodium is giving electron and becomes Na plus. This electron is taken by hydrogen. This bond is shifting. Therefore, hydrogen atom is created. This hydrogen atom is adding across the CC triple bond. Sodium in liquor ammonia converting CC triple bond into CC double bond. Okay. CC triple bond is converting into CC double bond. This nascent hydrogen is adding to this carbon, adding to this carbon. So here one hydrogen is added, here one hydrogen is added. Sodium in liquor ammonia converting CC triple bond into CC double bond and giving trans isomer. Trans isomer. Sodium in liquor ammonia converting CC triple bond into CC double bond gives trans isomer. Therefore, here one carboxylic acid will write, here one carboxylic acid will write. It is called a B isomer, B compound we can say. Okay. Therefore, we got this subjective question we got. We will go for a next question. We will go. We are going for next question. Next subjective question we will go. Now, undergoing periodic oxidation. Periodic oxidation gives 4 times formic acid and 2 times formaldehyde. Okay. A on periodic oxidation. A on periodic oxidation gives 4 times formic acid and 2 times formaldehyde. What is A? What is A? Sir. Formic acid how many times means 4 times. For formic acid 4 times. Formic acid is from which one in the sense? Formic acid is from CHOH group. CHOH group gives formic acid. Okay, how many formic acid means 4 times formic acid. Therefore, we will write 4 times CHOH group. We will write 4 times CHOH group. We have written. Okay, 4 times CHOH group we have written. We will give bond. Okay, carbon will make 4 bonds. Formaldehyde is from CH2OH group. CH2OH group will give formaldehyde. So one CH2OH group I have written here, another CH2OH group I have written here. Therefore, it is A. Okay. So what is A means this one. Okay. Sir. Next, next we will see what in the sense B with per iodic oxidation. B with per iodic oxidation gives 2 times formic acid and 2 times glyoxal, glyoxal, glyoxal. Sir, before going to this one, first we will discuss this. Okay. Now, per iodic oxidation means per iodic acid we have taken. Per iodic acid will break CC bond. Which CC bond? Vicinal diol. Vicinal diol CC bond will be broken. Here it is broken or not, see. It is vicinal diol, therefore CC bond is broken. It is vicinal diol, so CC bond is broken. It is vicinal diol, break CC bond. It is vicinal diol, CC bond will break. Vicinal diol, break CC bond. Therefore, it is converting into formaldehyde. It is converting into formaldehyde. These are formic acid. So vicinal diol will be vicinal diol CC bond will be broken. Otherwise, vicinal OH and vicinal carbonyl group CC bond also can be broken. Okay, one group is OH, another group is carbonyl group. That is vicinal means that CC bond also can be broken by what in the sense per iodic acid. Okay. Now here how many CC bonds we are breaking? We see 1, 2, 3, 4, 5. Therefore 5 times per iodic acid. Okay. So 5 times per iodic acid we have taken means 5 times CC bond we are breaking. That is the meaning. 5 CC bond we are breaking. Okay, we will see here. This B we have taken. This with 3 times HiO4 gives 2 times formic acid and 2 times glyoxal. Okay, one side oxalic group, one side carboxylic acid, one side aldehyde group is there. Okay, now we will see here. This formic acid 2 times is there, so I will write 2 times formic acid. 2 times formic acid I have written. This glyoxal I will write one side. Okay, one side I have written, another side I will write. Another side also I have written. Okay, in the 2 sides I have written. Now we will see formic acid is from what in the sense CHOH group. Okay, formic acid is from CHOH group. Okay, 2 formic acid, therefore we will write 2 times CHOH will write 2 times CHOH will write. Okay, here one bond we will write, here one bond, here one bond. Okay, then here formaldehyde we will get from CH2OH. Okay, now formaldehyde I will write like this. Formaldehyde is from CH2OH. Therefore, now here instead of this H, this COOH is there. Therefore, instead of CH2OH, this CHOH you write, instead of this hydrogen you write COOH. Okay, sir. So what we have tried means CH2OH we have tried, instead of one H we have tried COOH. Okay, so we have written like this. Both side we have written like this. Sir, now we will see periodic oxidation. per iodic acid we will give. Okay, this carbon is having OH group, this carbon is having OH group, vicinal diol, therefore this CC bond will break. Okay, here this carbon is having OH group, this carbon is having OH group, therefore this CC bond is breaking. This is also vicinal diol, therefore this CC bond is breaking. So for this one periodic acid, for this another periodic acid, for this another periodic acid, that means this compound requires 3 HiO4. See, 3 HiO4. Okay, therefore this compound, this is the compound on periodic oxidation gives so and so result. Okay, next we will take, we are taking a tertiary butyl alcohol. We are taking tertiary butyl alcohol with ethanol, in the presence of concentrated sulfuric acid on heating. Concentrated sulfuric acid on heating gives what product? Gives what product? This is the question. Okay, so now we will take a tertiary butyl alcohol. We will take tertiary butyl alcohol. We are taking tertiary butyl alcohol. We have taken. Now in this tertiary butyl alcohol, concentrated sulfuric acid we will take. Concentrated sulfuric acid, here coordinate bond, dative bond is possible between oxygen and H plus. Therefore this dative bond we will write it as a normal covalent bond. Now oxygen will give positive charge. Now SN1. Okay, therefore this bond is shifting to oxygen, water is leaving, so carbonium ion we are getting, tertiary butyl carbonium ion we are getting. This is reacting with the ethanol. This is reacting with what? In the sense ethanol. Now ethanolic oxygen is attacking this C plus, therefore we will get what? In the sense CH3, CH3, and ethanol we will write here positive charge. From here H plus will be removed. From here H plus will be removed. Therefore what we will get in the sense tertiary butyl ether ethyl. It is tertiary butyl, it is ethyl ether. This is the product we are getting. Okay, so we got so and so product we can say. Okay, we will take next question. We will take benzene. You are taking benzene. Then this benzene is treated with what? In the sense this benzene is treated with a so and so compound. So and so compound. Okay, so what is obtained? Then here what is there? In the sense BF3 boron trifluoride or HF, boron trifluoride or HF we will take. Then we will get a C. This C is taken for what? In the sense first one is HgOCOCF3 twice plus phenol. Then taken for reaction with sodium borohydride with OH minus gives D and E. Then the C with first mercuric acetate, THF and water. Then sodium borohydride and OH minus gives what? In the sense F and G. Then this C is taken for reaction with diborane plus THF. Then taken reaction for hydrogen peroxide and OH minus. What is obtained means H. Now we have to find all these things we have to find. C, D, E, F, G, H. We have to find these, we have to find. So what we have, how to find these we will see. Okay. Here now How to find this? We will see. Here one correction is there. It is what in the sense OH group. Here we will take OH group. We'll take. Okay. So now first we will see what is C. We will see. Okay. First, it is treated with what? BF3. Benzene will not react with BF3 or HF. This will react with BF3 or HF. How it is reacting, that we will see. This O